What's up, Calc Gang? All right, we're doing some initial value problems today, and we're gonna use some cool techniques, right? Okay, so we got the y double prime, the y prime, the negative 2y. So how we're gonna integrate this? Well, we're gonna use a cool technique, and I'm gonna try to run you through it today, while also not making myself look too stupid. Okay, so when you have this, when you have something that looks like this, you know, it's equal to 0, it's a homogeneous thing, you go, say y is equal to e to the rt, and then therefore that'll be y prime is equal to r e to the rt, of course, by power rule. Y prime is equal to r squared e to the rt. Okay, so then you can go ahead and substitute all this stuff into your equation here. So what you'll get is r squared e to the rt plus r e to the rt minus 2 e to the rt is equal to 0. Then you can factor out an e to the rt. And then r squared plus r minus 2 is equal to 0. Okay, so we're going to try to find the values of r where this satisfies our equation. Okay, so we look at the outside here, you think like maybe when this is equal to 0, but you'll notice that this never does equal 0 because it's e, it's an exponential, and therefore it'll never equal 0. So the only values where r would, or where this equation would be satisfied is where the inside is equal to 0. So to do that, we're going to factor some stuff out. So e to the rt, and then looking at this, it's going to be r to the negative 2, r minus 2, and then r plus 2, r minus 1, because these will multiply to negative 2, and then this will plus 1. Yeah, this is like middle school, right? Okay, so that gives us our two values of r. So r1 is negative 2, r2 is equal to 1. Those are what we need. Okay, so what we can do here is we can go ahead and make our equation. So you can say y of t. Don't ask where this comes from because it's kind of confusing, and I'm not going to explain it, I'm going to solve. So constant 1, e, and then this is r1, so it'll be negative 2t, plus c2, e, and then to the 1t, so just t. Okay, this is our general solution to this differential equation, right? Okay, so pretty cool. Now we need to find our values of c, right? Okay, so we can do a couple things here. Let's find the derivative, because we're going to need the derivative for this. That's why it gives us a constant. So y prime of t is equal to, the negative 2 will come down, so negative 2 c1 e to the negative 2t, plus, and then this will stay the same, c2 e to the t. Okay, so then what we can do is we can plug in our initial values. So y prime of 0 is equal to 1, and then you plug in 0 for all these, you'll get negative 2 c1 plus c2. And then this is one thing we need to use here. And if you plug in, y of 0 is equal to 1 for this one, y of 0 is equal to 1, and is equal to c1 plus c2. Pretty nice. Okay, so what we're going to go ahead and do is try to find what c1 is equal to, and then we can find out what c2 is equal to. So to do that, I'm going to set up a little charts here. So we're going to say 1 is equal to c1 plus c2, and then here you're going to go 1 is equal to negative 2 c1 plus c2. And if you want to get things to cancel out, we're going to have to subtract this equation from that equation. So 1 minus 1 is 0. c1 minus negative 2 is equal to 3c. And then this minus this is equal to 0. Did I do this right? Probably not. Hold up. Actually, I probably did do it right. Yeah, I did do this right. Okay, I'm tripping myself out. That means that c1 is equal to 0, right? That's the only thing that satisfies this equation. Okay, so we have c1 is equal to 0. Let's plug it back in to this equation here. If c1 is equal to 0, we're going to see that this, is 0, and then c2 is equal to 1. Okay, now we have our two things, right? All right, so y of t is equal to 0, so it's going to be 0, and then plus 1 e to the t. So there you go, we figured it out. Y of t is equal to e to the t is our general solution, or not our general, our specific solution to these initial values. And yeah, so it also wants us to sketch a graph of the solution and to try to determine its behavior towards infinity and negative infinity. This one should be easy for you guys. It's going to do that. It's going to have, but we even know it says it goes through 0 and has a value of 1, so at y of 0, which is, what am I talking about? Oh yeah, t is equal to 0, y is equal to 1, which makes sense, and its slope here is also equal to 1. Makes sense. We know it's going to approach 0 at negative infinity, infinity at infinity. Yeah, so that's how you solve this kind of problem. Yeah, good luck on your differential equations homework, guys. Stick around for some harder problems coming up next, right after the break.